Hi, I'm Josh Stella. I'm the CTO and co-founder of Fugue. Prior to founding Fugue, I was at AWS, and I've been a software architect and developer since the early 90s. Today, I'm going to talk about, so what Fugue does, when I was at AWS, what I did was I was a principal solutions architect largely focused on national security applications. So I've spent my career bouncing back and forth between tech and startups and high sensitivity kinds of applications. And so I think a lot about security, but I'm a developer. And Fugue is a company that exists to bring security to developers by developers. So that's what we're about. This is not a pitch about Fugue. The presentation today is about cloud misconfigurations. I'm going to talk about what that means, why it's a risk. I'm going to actively hack my own AWS infrastructure. And then I'm going to give you some recommendations, and hopefully there are some folks in the room who have some awesome ideas that I haven't had on recommendations on how to prevent this kind of attack. So everything I'm going to show you today is based on real stuff, real analysis of actual breaches of cloud security and our analysis of those. So this is real world stuff. If any of you are pen testers, I'm not. So you're probably better at that part than I am. I'm a software architect. I'm a designer. But hopefully you'll get something out of this. So the agenda, I just went through this overview of cloud misconfiguration. I'm going to do a live demo, actionable steps, and Q&A. And you'll probably catch me making errors because I'm going to spend a fair amount of time at the actual shell typing today. But first, some slides. Cloud misconfiguration is a major security risk. So these statistics on the right, Fugue has tons of big customers in enterprise. We did a survey last year of 300 organizations operating at scale on cloud about cloud misconfiguration. So this 93% that are concerned for a major security breach came from that survey. And I'm going to show you some other statistics from that survey as well. But Neil McDonald at Gartner, nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes. And that sounds kind of accusatory of us that are cloud customers, but it's also accurate. And what I'm going to talk about as we go through this is that getting this very complex combination of services configured properly is quite difficult, but it is essential. And that's because the cloud has so many awesome capabilities that if you get them a little wrong, bad guys exploit it. So we're going to put on a black hat tonight for a little while. So in that same survey, we asked folks, what are you worried about in cloud misconfiguration? 66% said access management, which in AWS is largely IAM. 59% security group rules, firewall rules. 51% S3 buckets, so object storage, and a little less than half encryption in transit. I found this to be prophetic as we've had a series of high-profile breaches of cloud infrastructure recently due to misconfigurations, and they are due to IAM, security group rules, and object storage access policies. So our surveillance were correct. This is what you should worry about. So cloud misconfiguration is often overlooked. There are lots of ways to expose risk in that cloud environment. And one of the things we're going to do later is put on that black hat and start hacking in and see how far we can go and look for those flaws in that cloud infrastructure to exploit that you might not be thinking about. So many of these dangerous misconfigurations are not even recognized as misconfigurations by security teams. They're not in the big compliance standards. They're not in CIS benchmark. They're not in NIST, right? They're not in PCI. They're not in SOC 2. There's no strong guideline for this because the bad guys are moving fast, and this is a very new kind of environment in terms of exploit. They're not, as I just said, they're not considered policy violations by compliance frameworks. And I can tell you, I have never seen a cloud environment, including my own personal ones. The Fugue commercial one is locked down tight. But my personal ones that I've built in the past, I've never seen cloud environments that don't have some misconfigurations. It's really hard to get this right. So let's talk a little bit about hacker strategy. Like the movies have the hacker going after, a particular company or a particular entity. That's largely not what's going on now. That does still happen. But in part because of the cloud, this says before cloud and cloud, but in part because of the cloud, but largely because the evolution of how people exploit things. In the past, they would identify the target. This does still happen. There's spear phishing attacks. There are folks going after particular organizations and then search for vulnerabilities. But more and more what we are seeing, if you read carefully in the news, people are scanning every available IP address on the internet numerous times a day for any vulnerability. There are massive networks of black hats that are coordinated and non-coordinated who are looking for anything you have out there. They're doing this with automation. They get a catalog, a shopping list of organizations that have vulnerabilities. They can do this in minutes. And then they look for juicy targets out of that list and go exploit them. So what this means is, if you have a vulnerability that's exposed to the internet, you don't have days, you don't have weeks, you have minutes or hours before the bad guys know it's there and might have already exploited it if you're an attractive enough target. Okay, I'm going to walk the tightrope here and do a live demonstration of a cloud misconfiguration attack. Before I go to the console and start doing that, I want to describe a scenario, and this is a scenario I have seen before. So this is a visualization of a cloud environment. Over on the left here is the internet. As we go through, you see a couple of VPCs. And I have in here a maintenance host EC2 instance. And then over on the right here, I have my very attractively labeled customer records S3 bucket. So if I'm the bad guy, I want to find a way into the VPC, onto the EC2 instance, and steal the data in the S3 bucket. And what I'm showing you here is part of Fugue. We do this visualization so you can do discovery. But this is really just to show you that what we're talking about here is a scenario where we're trying to get through numerous stages of a breach to get to your data. You can see here this maintenance host, hitting the wrong button, is in security group B, which is my maintenance security group. So I've actually got that nicely configured in a fairly isolated security group in terms of I've set aside a separate one. I'm not using default. But the story behind this in the scenario is I'm the poor schmuck who's the on-call engineer at 1 a.m. on a holiday when the Italian director of operations calls and says, the system is down, your service is down, and I'm trying to close a deal, get it running now, and it's 1 a.m. So what am I going to do? I'm going to get that thing fixed. So I might do something like this. I might go into, and I probably have to relog into AWS. Let's see, my creds have probably expired. Oh, come on now. Do I have internet? That wasn't a hopeful sound. I do not. Excuse me for a sec while the guest network here was really slow, so I'm going to reattach to my personal hotspot here. And while I'm doing that, when I go in to fix something in AWS, I might, for example, set up a jump host, a Bastion host, to get into that environment. Right? That's a good practice. I don't want to try to log directly into production servers, so I'll put something in between. And I might, when I do that, all right, let me try this guest network again. Is it broken wires at 2019? When I do that, I'm going to have to give that Bastion host IAM privileges to go do maintenance. Are folks familiar with IAM? Yeah, okay, good. So you've built IAM policies, I'm assuming then. Let me show you why people end up with too liberal IAM policies. So it's 1 a.m. and I'm not sure exactly what I need to do to fix the system. My system's been built using ECS, Lambda, DynamoDB, RDS, EC2, and 5 other AWS services. I'm not sure exactly what I need. So let's go and just take a look at, even on EC2, what the choices I need to make to come up with a policy that will allow me to do this maintenance. Right? I'm not making excuses for anyone here. We should always have least permissive policies. Right? If you read the AWS docs on IAM, they start out by saying you should always have least permissive policies. And in fact, they also go on to say you should only start with minimal policies and then expand the list. This is the list just for EC2. Okay? And these have interdependencies. And not just within EC2. They have cross-service interdependencies. So it's 1 a.m., the managing director from Europe is telling me fix this now, and I create a fairly liberal IAM policy to fix the system. I get it running. I see that the service endpoint is correct. I reach back out to them and they're having coffee. And it's 4 a.m. And I say, you know what, I'm going to go to bed. And when I wake up, I'm going to clean up that stuff I built. But I'm going to leave it there for now until I know the system is working. And then a year goes by. This happens every day. Every day, to all of us. You know, no one is above this kind of problem. And that is why one of the themes of this, I'll get to your question in 1 second, sir. One of the themes of this talk is really about visibility and discoverability. You want 100% visibility for you and 0% for the bad guy. Okay, so why is it there for a year? Because you don't have 100% visibility. So there's a lot of work that goes into that. We like the visual approach, but you want 0% visibility for the bad guys. You had a hand up, yes?
Why would you build that stuff manually? What about a CFP? I mean, you know, it's all the out.
So the question was, why would I go into the console and build this manually rather than using CloudFormation or Terraform and other infrastructure as code language? Yeah. So the short answer is, I'm assuming all this infrastructure was built using infrastructure as code.
Yes.
I got the page at 1 a.m., something's down, go fix it. So if you've written a lot of infrastructure as code, you know that actually that is even harder than doing it manually, but it is repeatable, and that's its benefit. You can go through a CI/CD pipeline, 100% believe in infrastructure as code. Rarely is employed in problematic situations that are time critical because it adds time to the response time. That is the short answer, the realistic answer. So, so many times I've gone into, when I was at AWS and at Fugue, into customers that say 100% of our stuff is infrastructure as code. We have no configuration drift. We say, just turn this on and leave it on for a couple of days. 100% of the time they have configuration drift by manual intervention. And the reason is it is impractical that you can predict every need of maintaining and operating an infrastructure in advance. You should do it wherever possible, but at that 1 a.m. managing director on the phone, you're not like debugging a CloudFormation template. You are trying to get in and fix the problem that broke the system. Is that a reasonable answer for now? I mean, I've got a lot to go through, and I'm happy to talk after this. I actually have to do some travel, so I'm not going to be here long after it, but I will be around for a little while. We can drill into it. So does my scenario make sense? We've got this Bastion host, it's been sitting out there for a year. Guess what? It's got an operating system vulnerability. Remember, our hackers are now scanning every IP address on the internet. They see that. There's an SSH port open through the security group. There is a vulnerable host, and they get shell. I'm not going to simulate hacking shell. I'm happy to refer anyone to some really great papers and research papers that have been done on how to get shell. I'm just going to pretend like I got it and get into what I find to be the really interesting stuff, which is once you get in. So here I'm just shelling into a box. You can see here, here's my 4 packages in my Linux instance are needed for security. So this is my old Linux box, right? And now I've gotten into this Bastion host, and I'm the bad guy, and I want to steal data out of S3. So what's the first thing I'm going to do? I'm going to look at S3. Oh, well, look, the system administrator did his job, right? An error occurred, access denied, when calling list buckets. Not allowed to do that. My IAM role doesn't give me permissions. Well, I'm stumped now, right? I don't have visibility. I can't discover what's there. But there are other paths I can go down. And forgive me for copying and pasting, but I don't want to waste your time. Oh, right, let's take a look at this first. A lot has been made in the news recently of the, the terribleness of the metadata service, which I think is one of the most awesome parts of AWS and EC2. It's not terrible, it's great. So when I'm in this box, I can call a local URL on the 169.254.169.254 address, which connects me to the EC2 hypervisor and tells me metadata about that service. Why would you want this? The reason you want this is your credentials from your IAM role that this EC2 is running under are living in this and they rotate under this. So you don't have to rotate credentials. You know, when I share with you later, if you reach out to me, the white papers and the research that's been done on how to hack in to Amazon services, it's usually because somebody left creds in like an old EBS volume or an S3 bucket that gets found. With IAM and with the metadata service, you don't have to do that. The creds are there, they're being rotated, and let's take a look at those. So here I've drilled a little further in. I'm not just getting the listing of everything in the metadata service. I'm going into metadata, IAM, security credentials, and this is running under a role called maintenance role, IAM role, maintenance role. So here we've got a secret access key and a token. This looks really scary, right? This looks like the keys to the kingdom. These are the keys that wouldn't allow me to list S3 buckets. So who cares? So properly designed IAM in your production environment, particularly those policies that are granted to roles running in the infrastructure that somebody can get to, should be extremely limited in what they can do. And then if a bad guy gets your keys, it's not as big a deal. But we've got a fatal flaw in this infrastructure that hit the news recently. And that is that there's the ability within IAM, if you leave it on, to change roles. And this comes back to discoverability. So here, I'm just going to copy and paste in an AWS IAM list policy. So if you're not familiar, when I'm typing AWS S3 LS or AWS IAM list policies, AWS is the AWS command line interface tool that's resident on every Amazon Linux box that you run in EC2, right? That's all that is. So here, I'm going to go see, well, maybe if I can't see S3, maybe I can see what's out there in the IAM world, and I'm wanting to get to S3. So I'm going to do a grep, a search in those results for anything with both the string policy name and S3 in it. I'm looking for stuff that will give me access to S3. So here we go. There's a number of policies. The Amazon ones are Amazon managed IAM policies. I probably can't get to those. I know that because I'm a bad guy and I do this for a living. But there's that S3 read-write policy. That looks really attractive to me. Before I go a little further on this, I want to point something else out. When you read about these S3 breaches, one that was prominent in the news recently, 700 S3 buckets were breached. We don't know the record count. If I had to guess, millions, hundreds of thousands. Every one of those names has to be discovered. Right, back to discovery. You want 100% visibility for you, 0% for the bad guy. The bad guys, I'm in the dark still, right? I'm the bad guy here. I don't know what's out there in those S3 buckets. So I need to find those list permissions in order to extract that stuff, or there's no way I'm going to guess 700 bucket names and 100,000 records per bucket name. It's just not feasible, right? All right, let's assume this IAM role. When you see people talking about assuming roles, this is what it's talking about. So we need to do a little more spelunking first. I now know there is this policy called S3 read-write that looks pretty juicy for my nefarious purpose, but I need to do a little more work before I can really exploit that. First, I need to understand my EC2 instances profile associations. Right? This is getting kind of far down in the weeds of EC2, but I promised a live demonstration of exploiting these things. And there's a really important thing to note there. As I'm getting down in the weeds that you might not be thinking about, the bad guys are. They are aware of every dark corner in AWS's APIs and how they can exploit these infrastructures. And so this stuff is critical. It may seem really boring, but it's critical. What I'm looking for here is this association ID. And there we go. Oops. I'm a little nervous up here, guys. Let's go down to the bottom. There we go. I think, whenever my internet or my AV doesn't work, I just get a little off kilter at the beginning of one of these things. All right, let's go grab this association ID. All right, and I have this really long command spelled out here that I'm going to copy paste because it's really long. But I need to replace this ID, and we'll run this in 1 second. I need to get rid of my quote here. All right, so AWS, EC2, again, AWS command line, EC2, replace IAM instance profile association. The association ID of the existing association to my maintenance role, which didn't allow me access to S3. And I'm going to then change that to IAM instance profile name S3 read write. Boom. Okay, now the ARN down at the bottom here is showing me I've got S3 read write. Well, let's look around again. We did an S3 list. Oh boy. So I see customer records. That looks cool. Oh, if I could type. Not sure I need the S3. Oh yeah, there we go. So these happen to be vacation pictures I took on a glacier, but if this was your infrastructure, this might be 100 million user records. An interesting command that was specifically cited in a Department of Justice document that came out not that long ago was the word sync. I'm going to show you sync. AWS S3 sync. I can point at one bucket. Oh, thank you, thank you, thank you. And I'm going to point to where I want all your data. So all your base. I have all your data. I have all your data. If I had an ls and a sync command on those buckets, I had the ls for the 700, I've got them, I sync them all. None of that traffic traverses your network perimeters. The only evidence you have that that happened are the API calls when you go back and look in the logs later. And guess what? Now, there are services like Macy, which is awesome, that will try to protect against this and catch it in flight, but I would argue prevention Prevention. Do not let these things happen because the speed is so great. So one of the recent breaches, it was 135 days from the actual occurrence of the breach until anyone knew about it, and that was only because the hacker bragged on social media. So how many of us have been hacked in this way and don't know? Probably more than we know about. So cloud misconfiguration is a devastating attack surface if you get it wrong. However, it is 100% preventable by having the ability to do discovery and follow good policies in your environment. I love your input. This should be templated, right? Yes, there should be rules. I don't know that they can always be handled in the form of infrastructure as code at runtime, but there should be policies, and you should be watching for these things. And you should be watching for the precursors of the event in which your data is actually stolen. So one of the things we like is, and again, this is Fugue, is the notion of keeping track of drift events. So here, oh, that's actually me fixing it. Let me show you the bad guy getting in. So here we've got some drift events. We're tracking the infrastructure configuration, and here I can see, hey, somebody went from a maintenance role to an S3 read-write role. That sounds pretty bad. Maybe I should do something about that. That happened. That event was triggered in Fugue back when I ran that assume role command, right before I went and stole the data. The other thing is have really good policies around security groups, around discovery of infrastructure. I'm running late, aren't I? And on things like IAM permissions. So we do have a few recommendations. I'm going to jump back over to my slides. The attack and review. Number one, I had to have an open port. I had to find an open port with something weak behind it. Often these are drift. You know, we often see security groups get ports open that people don't notice till much later. It's just very common. If you go back to your office and you find more than 100 security groups, you should start worrying, in my experience. Dozens of security groups are hard enough. Hundreds get really, really tricky. I have often seen thousands. So two, I got into an EC2 instance. That can be an unpatched instance containing a vulnerability like we talked about. It can also be things like credentials that were in a GitHub repo that some bad guy found, or in one of your S3 buckets, they find something that says uname password and some Python code or whatever it is, getting into that EC2 instance. Three, I needed an IAM role that allowed me to hack the infrastructure because the IAM role that was there was actually pretty good. It didn't let me at that data. And then four, I would argue more important than the ability to read data from S3, more dangerous is the ability to discover S3 buckets and list their contents. The discovery aspect, if you're a bad guy sitting there at a command line shell like I was, how are you going to guess? You might go find an SSL cert for a single bucket name. You're not going to go figure out 700, and you're not going to go figure out 1 million object names, right? So key takeaways, constantly monitor all access port configurations. I think anything slower than about 5 minutes is dangerous, personally. Apply principle of least permission. This is much easier said than done. If you remember when I showed you the AWS console and the hundreds of things that you can configure, and it's a Rube Goldberg machine of epic proportions to get a mental model of how these IAM roles work together. If you don't have someone on your team who's passionate and fixated on that, you should. Or you should be using a tool like ours or somebody else's that will help you analyze those things. A few simple thoughts, though, on IAM roles. Maybe use different endpoints for read and write operations, or even for list and write operations. And eliminate S3 bucket listing in production environments. So what do I mean by production environments? I don't mean your IAM role that you log into the console with to do maintenance. I mean the ones you've assigned to EC2 instances in the infrastructure. Be very afraid of what's assigned to those EC2 instances, because if a bad guy gets shell, they don't even need to root that box. They've got everything that IAM role, or if you leave IAM roles that allow attaching or replace roles, any IAM role you have, they have access to. So some other things, ruthlessly clean up unused cloud resources. Be utterly paranoid about this stuff that's hanging out there. I've rarely seen an organization that actually knows what north of 70%, maybe 80%, if they're really good, of what they have in the cloud is doing, who owns it, or its current status. That is extremely dangerous. Orphaned resources are not just cost. They are massive security holes. Hire pen testers who know how to do what I just did. Hire pen testers that are as good as the bad guys at this stuff, because traditional pen testers are thinking about operating systems, they're thinking about traversing networks. I just showed you IAM is a network. And you need good guys playing bad guys who know that stuff. And then I think you need to use automated remediation. We certainly have spent years building that stuff ourselves. Things like VPCs, S3 buckets, security groups, EC2, and IAM. Your edge, most vulnerable stuff, you should not have to launch a ServiceNow ticket and go into the console and fix. A system like Fugue, and there's other ones out there, can automatically fix these things for you. All right, and we've got 5 minutes for questions, but I'll be around after this. So any questions? Sir?
Why don't we do something like, WAF right up front, and you have your storage buckets, empty buckets. No one, I won't let you connect from a CLI. There's only the application that can connect, or if you are happening, you're coming into a different route altogether, which will be really difficult to find the IP or the path to that, or the endpoint to that.
Yep.
Unless you know the IP address, which is local to the resource, the AWS IP address, and not the public IP, which will be extremely difficult to get that.
It's a good question, and it shows the difference between cloud and kind of data center exploitation techniques. So the cloud exploiter doesn't care about IP. There is no IP in the attack I just showed. So actually, in the real world example that I'm emulating here, it was a WAF that got exploited. So the question was, why not put a WAF in front of all this and not allow those kinds of transactions through? So the WAF was exploited to share its IAM creds, which allowed access to shell, and then none of the other attack traversals that I just did are IP based. I never looked at a single network node. It was all IAM traversals. I'll definitely talk to you later if you want to keep going. Are there any other questions? Yes?
So usually for Bastion hosts, you can always attach only the security groups, right? Not any IAM, nothing. So in that case, could this have been prevented? Like you don't store any IAM credentials, nothing. All it has is like a security group attached with inbound and outbound rules, and that's it.
Okay, so the question is, why use IAM at all for a Bastion host? Why not just have a security group with no IAM role at all? So no IAM role means one of two things. You either have no API access to AWS from the Bastion, right? Or you're using some kind of local creds that you've loaded onto the Bastion host, right? So which of those two are you describing?
So don't people usually like use Bastion just for tunneling? And you can always tunnel and run something from your local. And as far as you whitelist, and then like you execute the command from your local laptop, and then just use the Bastion as a tunnel.
Very few. So the question is, you should just use the. I don't know if it's an assertion. The comment is that the Bastion should just be used for tunneling, for doing things like SSH sessions, and you can use your local laptop for the API calls. I work with a lot of enterprises. I don't know any that have internet access to the AWS APIs for their accounts from local laptops unless they're going through corporate networks. So in this scenario that I'm picturing, it's a holiday, the VPN access isn't great, and so the customer set up a Bastion host to do that. It is a good idea. So I'm not disagreeing with you. Should you always use the approved method for connecting to the APIs? Yes, you should. I can tell you that this happens a lot. So, but that is a good suggestion, to not use IAM in a Bastion host, but instead just use it for tunneling and use your own local host through a corporate approved VPN to do the API calls. It's not a bad idea. Yes?
So what permission was granted so that you could actually assume the role of an IAM?
Okay, the question is, what permission was granted in IAM so that I could assume the permission of another IAM role? And the answer is, it takes quite a few. The answer is it's complicated. And the problem with that is, it's also complicated to do innocent things, right? It's complicated to just get the minimum permissions to do innocent things. So I think there's something like a half a dozen permissions across 3 services to do that assume role. And
that's where I'm going, I'm like, I mean, that sounds crazy, but that was like, how did they do it? Because there had to be somebody give that permission for them to do it.
So the way it happens is this: when I go into that EC2 console and I've got that managing director who has a big P&L center over in Europe breathing down my neck, and I go to give myself some permissions. Sorry, my network appears to have gone down and back up. Let's see if I have it back. And I'm confronted with, now keep in mind, I don't know what's wrong with the system. I don't know that I need to go into just DynamoDB or just Lambda or just RDS or just ECS, or maybe it's something running in an Apache process on an EC2. I don't know what I need to do as I'm going in. So when I go in to do this, and I am confronted with this, so okay, just list on EC2 95 permissions, all interrelated. Read, how many we got in read? Only 15 in read. Read's pretty non-hostile. Tagging only has a couple, but let's look at write. 228.
But none of that
So
will allow them to consume all.
actually, a bunch of these will. They need a couple other connections on. I think one in IAM and one in STS. I could be wrong on the exact details, but most of the assume role stuff is in here, is in EC2. So at least a majority of it. So why would I end up with this overly permissive scenario? It's 1 a.m. What do I need? Typically what will happen is you'll start with, well, it looks like I need this one, this one, this one, and this one. And then you'll try a command. And you know what you'll get back as an error is you'll get an error that your access was denied, and the reason it was denied is encrypted, unless you have IAM permissions to STS, in which case you can read the error message for what you might need to get the access you need. So this is non-trivial. And when people are in real-world operational situations, they tend to go overbroad. Now, I'm not advocating that, but I see it all the time. So I think this is, I'm one of these people when the press comes out and says, oh, these people screwed up, they misconfigured AWS, I feel for them, because this is one of the most powerful computing platforms ever invented by man. It has tremendous capability and flexibility, and keeping it all straight is really, really hard. So I don't think this is anyone's fault, except we need better tools to help us manage it. But I want to respect the next speaker's time. I think I've got time for one more quick one. I think you had one.
One question, that is, I don't see SSM mentioned nearly frequently enough. Pretty good run command, I mean, things that can be put into place that don't allow that. I've actually stopped using Bastion host for quite some time now because of SSM and what it provides, both session manager or run command, basically, just all those things. And that gives you that other layer of protection of getting to that. So
Yep.
That's those aspects of not worrying about security groups, not paying for a Bastion host, not maintaining a Bastion host, not having to mess with SSH keys on it, all those things. Use run command, use SSM and specifically run command. And then
Yep.
if nothing else, you've got stored documents for run command. You can only do these things with run command, etc. So there's a whole range of benefits in that.
I love that, and we were just going through a SOC 2 audit at work, and the SOC 2 auditors figured out that we don't maintain any operating systems at all to run Fugue. It's Lambdas, it's all
Lambdas and Fargate.
exactly. And so the comment though was, why not use a managed service SSM instead of doing a Bastion host? It's a great idea. My purpose here today wasn't to convince you that you should go make vulnerable Bastion hosts. It was to show you how these things happen and hopefully prevent that from happening. So thank you very much for your time. I'll be here for a few more minutes, a little while. My colleagues Drew here, my co-founder, and David back here. David will be here later, so feel free to reach out, and thanks again.